Complex conjugate.
Okay, hello, welcome to another episode of King Solomon and David Pikosi on algebra. Today we'll be looking at under complex numbers, we'll be looking at complex conjugate. Complex conjugate. Okay, so realize that in your high school, you guys did something called a set. So now when you say a set, what does it mean? A set is so you know that a set is an irrational number. A set is an irrational. So we normally say that boys under a root, sorry, digits under roots are normally what said, and we said when we are doing the number theory, we said it's what an irrational number. So now we said if we have two set like 2 plus 2, and you are asked to find the conjugate of this set. You have to find the conjugate of this set. You just change the opposition sign of the particular set, so that becomes 2 minus what? Root 2. Now, in complex numbers too, there are ways to find the conjugate of the complex number. So now let's take, for instance, that we have a complex number which is set as x plus I y. Now, if you are asked to find the complex conjugate of this particular complex number, it is denoted by z bar. So, complex conjugate is denoted by z bar. So, it is simply negating the imaginary aspect of the complex number. So, now the complex conjugate of a complex number z, which is the bar z, is simply negating the negating the imaginary aspect or the imaginary part of the complex number. So in this case, it becomes x minus I y. So this is the complex conjugate of the z. The z. So now, if you have, for instance, if you have something like this, if a complex number multiplies its complex conjugate, it leaves us with a real answer. If a complex number multiplies its complex conjugate, it leaves us with a real answer. So you can also say that a complex conjugate is the conjugate of a complex number when you multiply the complex number by the complex conjugate, it will give us a real part. It will give us a real part. Okay, so when we multiply the complex number by its complex conjugates, then this is what we get. So we're having x plus I y multiplying x minus I y. So now when we do this, realize that we'll be getting x squared minus x iy plus x iy minus y squared I squared. Okay, so when you do this, realize that this will take this away. You should be getting x squared minus y squared I squared. And take note that we said I squared is always equal to what? -1. So you have to do this all the time in complex numbers. I squared is always equal to -1. So therefore, I squared minus, into brackets, I squared minus 1. That will give you x squared plus y squared. And anytime you do this, you realize that this is the same as the modulus of the square of the modulus of the complex number. Because if I have a complex number at x plus iy, and I want to find the modulus gives me as well x squared plus y squared. And with this, if I square both sides, which I will get x squared plus what? Y squared. So now, giving us the real part. So anytime you multiply the complex conjugate with its complex number, you get a real part, x squared plus y squared, and that is the same as the square of the modulus of the complex number. That is their product. Okay, if that is the case, let's look at one or two examples. So example 1, with this example, we are asked to find the complex conjugate of z. Find the complex of z is equal to a plus 2i plus 3ib. This is a question and it has to find a complex conjugate. Now, what we do here is that to solve this particular question, we have to know the terms for the real part and the terms for the imaginary part. So we arrange this and we get a plus I into bracket 2 plus 3b. So we know that this whole part is the real part and this whole part becomes the imaginary part. If that's the case, the conjugate complex number space, we should negate the imaginary part. So that will become a minus I 2 plus 3b. And this is the complex conjugate of this particular complex number. Okay. I want us to look at one or two things here. Anytime you have the complex conjugate of, if you have z1 plus or minus z2, they are complex conjugate. These are some properties you have to know. It's the same as the z1 complex conjugate of the individual plus or minus the z complex conjugate of the z2. Again, too, if you have the complex conjugate of z1 and z2, their product, it is equal to their individual ones, z1 complex conjugate of z1 and the complex conjugate of the z2. You can find examples and improve this, and they'll all be valid. And the third one too, if you have division, complex conjugate of divided by the z2 is the same as the individual ones divided by the complex conjugate of the z2. So these are three properties under the operational signs: addition, subtraction, multiplication, and division. You have to note on that. Now let's solve one more example. Let's solve one more example. These are things you have to know. Let's solve one more example. Let's solve one more example. But you have to note that if you have z plus iy, then the complex number is equal to x minus iy. Okay. So now the question says that you should find the complex conjugate of the complex number. And this is a complex number. Z is equal to w into bracket raised to the power 3y plus 2ix, where w is equal to x plus 5i. Okay. This is the question you have to find the complex conjugate of this particular complex number z. So now to do this, you have to put the w, which is equal to x plus 5i, into the question. So if you put it into the question, we are getting x plus 5i all raised to the power to 3y plus 2ix. Now, complex conjugate simply says negate all the imaginary part. Negate all the imaginary part. So therefore, to find the complex conjugate is equal to x minus I5 raised to the power 3y, which is the real part, minus I2x, which is the, and this becomes the complex conjugate. This becomes the complex conjugate. Properties you are supposed to note again, aside operational properties. These are properties you are supposed to note again. That anytime you have a complex conjugate of a complex number, and you have the complex conjugate of another complex conjugate, it is equal to the complex number. So now this is what it means. If you have x, z is equal to x plus iy, and you find the complex conjugate, which is x minus iy, then you want to find the complex conjugate of this particular complex number now. That is this, which will give you x. You have to negate the I again. So if you negate that one, I1, you are getting x plus I1. And this is the same as this. So therefore, anytime you have the complex conjugate of another complex conjugate of a complex number, it is the same as what? The complex number. 2. If you have a complex number plus its complex conjugate, then it's the same as 2 times the real part of the complex number, which is what? 2x. It's the same as 2 times the real part of the complex number, which is what? Which is 2x. So that is to say, if I have a complex number, this is the complex number 2x plus iy. My complex conjugate is simply x minus iy. So I want to add x, z plus my complex conjugate. So this says that we add the real part and we multiply we add the imaginary part. So now it becomes x plus x, and we add the imaginary part, which is plus y, and here it's minus y, minus y. So you realize that this part will go to 0, so you get what? Which is 2y, 2x. Okay, so now anytime you have a complex number multiplying its complex conjugate, it is 2 times the real part of the complex number, the same as 2x. And the last property speaks that if you have a complex number minus a complex conjugate, it is equal to 2 times the imaginary aspect, and that is equal to 2yi. Okay. So now if you have a complex number minus a complex conjugate, it's 2 times the imaginary aspect, and that is 2yi. You can prove that from what I did here for the second property. Thank you very much for joining this class, and I believe you get a lot of questions to solve. Bye.